Newton's first law. Okay. So already we have discussed about this in our bridge course. What exactly the Newton's laws of first law is suggesting. Okay. So directly I will go with the what its definition, because already we have discussed a lot about the inertia. Okay. The same thing what he has given in his first law. Okay. So what we can say is every body in the universe continue to be in the state of rest or motion unless an external force act on it. Okay. So every body in the universe, every object in the universe is continue to be its state of to be in the state of rest or motion unless an external force act on it. Okay. Suppose a body is at rest, so it continues to be at rest unless force apply on that. Okay. So if there is no force, it continues to be rest. Similarly, if body is already in moving with say uniform speed, that is very important, uniform speed. Okay. So if it is moving with uniform speed, then what you can say, unless a force act on it, you cannot bring it to the rest or you cannot change its direction. Okay, that is what given by first law. So this is nothing but the property of what? It is nothing but the property of inertia. So it is also called as what? It is also called as law of inertia. It is also called as law of inertia. Okay. So why they have mentioned the net external force unless what is rest or motion unless an external force act on it. Okay. So sometimes you may ask me then, if suppose a force of 10 Newton is acting on this side, so obviously body will move. Okay. So if suppose 10 Newton acting on this side, again 10 Newton acting on this side. So now what will happen? You cannot change the state of body. Can't change state of body. Why? Even though force is acting, but net force, F net is what? F net is, this is along this direction, so this is what opposite direction, so take negative. So net force is going to be 0. Okay. So that is why what I can do here is every body in the universe continue to be in its state of rest or motion unless an external force act on it, or shall I write it as unless a net external force act on it, or simply you can say unless an external force act on it. Okay. So this word net external force is very important. Net external force. Okay. Because simply it doesn't mean that if two forces are acting on two sides, then body may not move. So that is why net external force is very important. Okay. So same examples we have taken here. Okay. So to make a move of the body, so net external force should not be what? Should not be equals to 0. Then only you can change the state of body. Change state of an object. Okay. If you want to change the state of an object, so net external force should not be equals to 0. Okay. So if net external force is 0, if F net is 0, so what you can say? You can say that body acceleration is 0. So body can't accelerate. Or if body is not accelerating, if body is not accelerating, means what? It means that the net force acting on it should be 0. This is what given by the first law. Every body in the universe continues to be in state of rest or motion unless an external force acts on this. That external force is what? That external force is net external force act on it. Okay. So this should be you should be what clear about the net external force. Okay. An example from your tensor. Suppose there is a spaceship. Okay. And astronaut will jump from here. Okay. So suppose astronaut means you have to. Okay. This is what astronaut. When he jump outside in the space. When he jump outside in the space, there are no nearby planets. So there is no gravitational force. There is no gravitational force acting on him. Or it may. If there is no gravitational force, so this person will not be acted by what? Will not be acted by any kind of forces. That means the net external force is what? It is going to be zero. So if net external force is going to be zero, obviously there is no acceleration. There is no acceleration means what? With what velocity he jumped, with the same velocity he keep on moving. So what will happen? He will move with uniform velocity. We simply move with the uniform velocity. Okay. Then you may ask me a very, very important thing, that is what about the objects present on the body? Suppose there is a table. Okay. Suppose there is a table. On that table, so there is one book lying. Okay. So you can say there is one book lying on that. Now this book is at rest. This book is at rest because no external forces are acting on that one. This book is at rest because no external forces are acting on this one. So from this side or this side, F is what? F is 0. So then you can ask me, everywhere you can go on the surface of Earth, there is a gravitational force. So gravitational force is there. That means there is acceleration. There is a acceleration, that is what equals to g. If there is a acceleration, so obviously what will happen? F net will not become 0. F will not become 0. Then also why that book is at rest? Because it doesn't mean that forces are not active. Obviously gravitational force is active. Similarly, this force will act some force on. This table will act some force or not. On this book, that is what? Force acted by table on the book. Force acted by the table on the book. Okay, so that is what we call it as. We call it as normal force. Okay, so that is what we call it as normal force. Normal force. So book is not moving. Book is not moving. It doesn't mean that no forces are active. Okay, so book not moving doesn't mean that no forces are active. Book is not in motion doesn't mean that no forces are active. No forces are active. But net force is 0. So if that book is at rest doesn't mean that there are no forces acting on the book. Obviously gravitational forces, so they are everywhere. So obviously it will get acceleration, it has to move. But it is not moving because of the normal force acting on the book by the table. That normal force is equals to what? That normal force is equals to the gravitational pull of the earth. So net downward is equals to upward force. So that is why they will get cancelled. Okay, so that is why. So gravitational force is equals to what? Normal. So that is why the net force. So net force becomes 0. Okay, so F net will become 0. So that is why the book is not moving or book is not accelerating. Okay, so you cannot say that since Fg equals to n, so book is at rest. Book is at rest. This statement is not correct. Okay, because we don't know only how much this one and this one, and we cannot say simply they are equal. But we can go in reverse order. What is that? Book is at rest. Book is at rest. It means that the gravitational force may be equals to normal force. So this we have derived from this statement, not this statement from this one. Okay, so that is a different thing. Don't worry much about that one. But that is what the meaning of the body is at rest. Body is at rest means that the force acting on the book by the table is equals to the downward force acted on the book by the earth gravitation. Okay, so gravitational force is equals to normal force acting on the book. Okay, so this is what one very important example. Similarly, let me go with another example of acceleration. That is what the motion of a car. If you take the motion of a car, suppose you are having a car over here. Okay, so what will happen if you want to start? Okay, now car is at rest. So you have to apply the external force. Why it is at rest? Because the any force acting in this direction is equals to frictional force. Getting the point? No, why it is at rest? Because of the frictional force acting on this one. Okay, or no forces are acting. No forces are acting doesn't mean that car is what? There are no forces. Obviously, this gravitational force is there. So normal force is also there. So they are equal and opposite. So it is at rest. Okay. So if you want to move it, you have to apply the force. It doesn't mean that you have to apply the force. What you have to do? You have to prove that net force is not equals to 0. You have to prove that net force is not equals to 0. Then against what we have to do the work? There is a frictional force. Okay. So if you want to make car to move, you have to cancel this frictional force. So this frictional force should be equals to the force applied by that one. If you want to accelerate the car, if you want to move the car, beginning you have to accelerate. That means you have to apply the force. So force applied by you on that acceleration. So what will happen? You are giving acceleration means you are applying the force. So force applied by you should be equals to F net. So till then it will not move. So one force you are acting is F, and there is opposite force. What is that? That is what the frictional force. Okay. So this is what frictional force. So when this applied force becomes equals to frictional force, so what will happen? At that time, so net force will become what? Net force will become 0. So then the car start moving. Then no need to accelerate it. It will move with a uniform velocity. Okay. So again, if you want to stop it, what you have to do? You have to again apply the force, so that it should become less than what your applied force should be what? It is less than the frictional force. Then what will happen as the frictional force got increasing, so car may come to the rest. Okay, so these are the simple examples in our day-to-day life which can deal about the Newton's first law. Okay, so what first law suggested? Every body in the universe is going to be continuous state of rest or motion unless an external force acts on it. So we'll go to the second law. Second law of motion. Okay. So for the first law, as usual, you can give many examples which we have discussed in our the inertia. Okay. So why we will feel like falling forward or backward when the bus or vehicle start moving, or when it comes to rest, or the shaking of the branch tree when the leaves fall down and cleaning of your mat. So those all examples which we have given for inertia will be applicable, or will be the examples for the what your first law of Newton. So you should know the examples also. So second law. So before going for second law, one more very important thing that we should know, that is what effect of force. So how we can find the effect of force. So how much, whether the effect of force is more or effect of force is less, because the same force applied on different bodies, the effect will be different. Okay, if you apply the same force on the glass is different, if you apply the same amount of force on the some metal is different. Okay, so effect of force will be different. Okay, suppose there is a bicycle. Okay, suppose there is a bicycle, and if this bicycle go and hit a person, so what will happen? The effect of force may be less, because it's a bicycle, because its mass is less. Mass is less. Instead of this one, if suppose there is a truck, okay, suppose there is a truck and this truck go and hit a person, so effect here is less, here effect is what? Effect is more. So effect of force is more over here, because of what? Because mass is more. Because mass is more. Okay. So similarly, when if you are standing on a building and two balls are dropped from here, okay, one is of lightweight, one is of heavy. Okay, say it is of, one is of metal, one is of some plastic. Okay, so what will happen if you are standing over here? So you will catch both the balls. Which one will hurt you more? So the metal will hurt you more. Okay, so metal will hurt you more, because force is more, or that means effect of force is more. Here effect of force is less. Here effect of force is less. So that means it depends on what? It depends on mass. If mass is more, the effect is more. If mass is less, effect is less. That means the effect of force is directly proportional to what? Is directly proportional to mass. Okay. So if mass increases, effect of force increases. If mass decreases, effect of force decreases. This is what effect of force, not force. Okay. So we should know effect of force. Okay. So similarly, so that means what? The effect of force depends on what? Effect of force depends on the mass. How it depends? It's directly proportional to mass. Okay. So similarly, it may depends on one more thing, that is, suppose if a bullet is shot with a high speed, so this is what? High speed, and a person is standing over here. Okay. So now what will happen? The effect is what? Effect is, you will dead only. Okay. So effect is more. Because of what? Because of high speed or high velocity. Okay. So similarly, instead of this one, suppose if the same bullet of same mass is thrown with, or is shot with a less speed, if speed is less, so what will happen? He may hurt, but he will not die. So effect is what? Effect is less. Getting the point? Similarly, when the cricket ball comes like this, you can easily catch it. So effect is less, because coming with the less speed. Getting the point? But when it comes directly, okay, if batsman is here, he is hitting directly. Suppose you are the fielder inside the circle, 13-yard circle. Then what will happen? When you catch this, the effect is what? Effect is more. Because what? Because speed is more, or velocity is more. That means the effect of force also depends on what? Also depends on the speed or velocity. Okay. So how it depends? If velocity is more, effect is more. If velocity is less, effect is less. That means effect of force is proportional to what? Is proportional to velocity or speed. Okay, so velocity or speed. So this is what how the effect of force depends on its mass and velocity. There are two quantities on which it depends. Okay, so if velocity increases, effect of force also increases. If velocity decreases, effect of force also decreases. That means effect of force depends on two quantities. Effect of force depends on two quantities. What are those? They are nothing but its mass and its velocity. Okay, so this effect of force which depends on mass and velocity, it is called as what? It is called as momentum. It is called as momentum. So momentum is equals to what? Momentum is equals to mass into speed or velocity. Okay, so symbol you can write it as P equals to m into v. Very important, P equals to m into v. This is what the momentum equals to mass into velocity. So how we can write the unit? Mass means kg, so velocity means meter per second. Okay, so now, so what is the physical meaning of momentum? Physical meaning of momentum is effect of force. But how we can define the momentum? You can define momentum as it is the product of mass and velocity, which is the product of mass and velocity, or simply you can say product of mass and velocity is called as what? Is called as momentum. And this momentum will give the what? Will give the idea of what? Effect of force. Okay, so which describes the effect of force. I would write, not required. If you write only this much, it's fine. Which describes the effect of force, or which gives the which explains about the effect of force, which describes the effect of force. Okay, so this is what we call it as the momentum. Very important. It is nothing but product of mass and velocity. Okay, suppose what is that? Momentum. We are not yet started about the second one. Momentum P equals to mass into velocity. So that is one thing. We'll see whether how this effect of force depends. Okay, so suppose this some cricket ball is coming over here. If you want to catch it, if suddenly if you catch from here only, suppose suddenly you catch here only, what will happen? Here effect is more. Why? Because it suddenly comes from some velocity, say some 10 meter seconds to suddenly 0. You are just holding this hand suddenly. Okay, so what will happen? So change in its momentum is what? Here say a ball is of say some 2 kg. So here also ball is of 2 kg only. So what will happen? So change in momentum, P1 minus P2. What is P1? 20 minus 2 into 0 will be what? 0. Okay, mass into velocity. So what will happen? Change in momentum is 20. Instead of this one, suppose ball is coming, same ball, so 10 meter per second. So instead of holding your hands over here, if you pull your hands from here to here, here to here, and here, finally if you take a ball over here, okay, you are just moving your hands with the ball. So what you are doing? You are decreasing its velocity. So suppose from 10 it is coming to say 15. Now it is coming to say 10. Now it is coming to say 0. So what is happening here? Here effect is less from here to here. You will not hurt more. You are just moving with that ball. So you are making what you are just reducing its velocity. So here if you look at the effect is less because change in momentum is what? Change in momentum is 10 into 2, 20 minus here 15 into 2. Okay. it is not 15, it will go on decreasing, it will become say some 8, then say some 5, then say some 0. Okay, so now it is what 8 into say 2, so what will happen, 20 minus 16, so that will become what, say some 4. So change in momentum is what, as compared to this, it is very less. Okay, so that is what effect is less, because force on your hands is less. That means what? That means force or effect of force acting on your hands is directly proportional to what is directly proportional to change in momentum. Change in momentum. That is, F is directly proportional to delta P. Delta P is what? Change in momentum. Delta P is equals to final momentum minus initial momentum. PF is what? Final momentum. Final momentum. So PPI is initial momentum. Initial momentum. Okay. So this is what the force is directly proportional to change in momentum. Okay. Then one more thing. Here, if you look at here, it has taken less time. Suddenly it came and you hold it. Okay. So it has taken what? Less time. Effect is more. Force is more. Here, to bring from here to here, it has taken what? It has taken more time. So effect is what? Effect is less. More time, less effect. Less time, more effect. Suppose something is dropped on the some glass is dropped on the say some floor. So what will happen? Suddenly it comes from some final velocity to 0. So time taken is what? Time taken is very less. Time taken is very less. So what will happen? It will broken when it hits hardly. What will happen? It will break. So effect is what? Effect is more because it is a glass. Okay. Time between interaction time is what? Very less. Suppose instead of that, on the same glass, if you throw it in some sand, okay. So what will happen? When you throw it, it will go for some distance. It will come here, but it will not break because time taken is more. Time taken is more. Time is more. So time is more means what? It will take more time to change its momentum from higher to lower. So more time taking means less effect. Less effect. That means you can say the force is inversely proportional to what it is. It is inversely proportional to say time. Okay, it is inversely proportional to time. Yes or no? Or change in momentum is also. Change in momentum is more if it take less time. Change in momentum is less if it takes the more time. Okay, so that also we can write. Change in momentum. Change in momentum is more if time is less. Similarly, change in momentum is less if time is more. Okay, they are inversely. So I can write it as, so force is inversely proportional to change in time also. Okay, less time taken, more force; more time taken, less force. So I will combine these together. So force is directly proportional to change in momentum and inversely proportional to change in time. Okay. So I will remove this symbol. So simply I will write it as equals to, I will take some constant k. So delta p divided by delta t. So k I will take it as 1, y and I will to take one, those all things will describe later. Okay. So f equals to, so 1 means no need to worry about that one. So delta m into p divided by, sorry, m into v. P means what? M into v. M into v. So m the constant, it will not change. So take m outside. So delta v divided by delta p. So this is what f equals to. Okay. So obviously this delta v by delta t is what? It's the acceleration. Or I will take a limit delta t tends to 0. So f equals to mass into limit delta t tends to 0, delta v divided by delta t. What is this? This is nothing but dv by dt. So F equals to m into dv by dt. What is this dv by dt? Rate of change of velocity. Rate of change of velocity means what? It is nothing but acceleration. It is nothing but acceleration. So F equals to m into e. So force equals to mass into acceleration. Force equals to mass into acceleration. This is what all about the second law. Now we are coming to the second law. What is that? F equals to ma. That means force applied is what? Directly proportional to acceleration produced. And in which direction it will produce? In the direction of applied force. So now I can write the definition for second law with the help of this one. You can write it as what? The acceleration is directly proportional to applied force and it takes place in the direction of applied force. If I go into your NCERT, so they will take this definition. So what is that? That is what force is. Force is directly proportional to what? Delta P by delta T. Delta P by delta T I can write as dP by dt. So force is what? Directly proportional to rate of change of momentum. Rate of change of momentum. Okay. So what is that? The applied force is directly proportional to rate of change of momentum. So this you can use to define the second law. Okay. So what you can write? The rate of change of momentum is directly proportional to applied force and it takes place in the direction of force. Okay. So rate of change of this was second law. Rate of change of your momentum is directly proportional to what? Is directly proportional to applied force. In which direction it will take? In the direction of applied force. In which direction you have applied the force, in that direction the change in momentum will take place. Or simply you can write acceleration is directly proportional to applied force and body will accelerate in the direction of applied force. Okay, or you can write force is directly proportional to acceleration. So anything whichever you are comfortable, which you can easily remember, that definition you can give. So mainly the second law concentrate on what? Concentrate on force. Okay, so just we have arrived at the formula of force, but there are a lot of things to discuss on the force. So that we will do in the next one.